I think it's a good time to talk about particle orientation and the orientation modifiers, look, spin, and turn. But in order to talk about these, we need to understand what a particle is doing when it's moving around space. So just like earlier, I'm going to make a basic emitter. I'm going to set it to a single point emission and shoot one particle. And in the properties, you can see we're going at a certain velocity in the z direction. Let's also go to the particle group and make our radius 4 so we can see this particle nice and clear, and you can see it's moving that way. Now, in order to understand orientation, I need to change the visibility here in a way that you can actually see the orientation of the particle. So I'm going to turn to handles. And you can see that we have the 3 axes. The blue one is not very visible because it happens to lie on the same color. But one thing I'm going to do just to make the particle swim around is just go and add in my scene a turbulence and change the parameters, my little triangle here. That always works nicely. Now watch this. And first of all, before I press play, think what you expect the particle to do. Let me deselect everything and press play. So let's look at this particle. It's moving in certain directions, but its orientation is not changing. Now, let's not forget that in Cinema 4D, moving forward is by default moving in the z direction. But you can see that this particle is not moving like an airplane as you would expect it to bank and pitch and all that. But it's only pointing in the plus z direction. And if I go to the top view here, you will see much clearer that the particle is moving in all sorts of directions, but its orientation is always the same. And let me extend this so we can see it for a bit longer. That's because we haven't told the particle to rotate or orient in any particular direction. Now, without doing anything with the modifiers yet, let me turn off this turbulence and go to the basic emitter here. And you will see that down here in the properties, let me close everything that's not important. Let's close everything. You can see here we have alignment. So in the alignment, it's telling you that the particle is oriented originally towards the velocity direction with an up vector of y. So that's why the particle, when we emit it, has an up vector of y. So the global y is up, and the direction it's going is the plus z. It's the velocity direction. This applies to the instant it gets emitted. Now let's close this little group and open the angular velocity. Currently, it's set to 0 with a spin vector of 0. You need to get used to opening everything you can to see what's underneath. And what I'm going to do now is tell it to have some sort of angular velocity. I'm going to set this to 30 degrees with no other variance, and the spin vector is the velocity direction. So it's going to spin around the axes it's traveling. And currently, this spinning is on the z-axis. So we should see our particle spinning this way, like that. So let's see how that works. Rewind, of course, and look at that. It is spinning around its axis with a rate of 30 degrees per second. Now let's test that for a second. If I make this 360 degrees, I assume that at 30 frames, and I'm going to stop the animation here by going to the animate and changing the playback mode to simple. This won't wrap around the animation, so I'm going to press play and wait it to finish. And you can see that it's approximately 360 degrees. Now you will see some variance in some of these numbers, especially when you have the continuous mode on. And that's because in order to avoid banding, which means that particles are generated exactly on the frame at exactly the same position, at exactly the same rotation, you do get a bit of offset with all these initial values. If I turn off the continuous, you will see that at 30 frames it's going to be exactly 360 degrees. We are going to talk about the details of the continuous later on, what it does and what side effects it has and what problems it fixes. But for now, we have this mathematically accurate particle moving from frame 0 to frame 30 while performing a 360-degree spin around its traveling axes, the z axes. Now, having said all that, and now I guess you have some sort of understanding what these spinny things are and all that, let's go back and reset this. Right-click, reset to default. And what I want to do is go back to my turbulence. And again, a particle is swimming and doing its great little stuff. Again, let me extend my timeline. Rewind, press play, and it's going around. So how do we make the particle, first of all, always look in the direction it's traveling? Well, that is achieved through the look modifier. The look modifier, which if you want things to work 100% properly, you have to think about what's executing before. First, the turbulence is going to modify the way this particle is moving, and then the particle is going to orient itself. It's going to look in the direction of travel. There you go. The forward vector is the velocity direction. And the up direction is the alignment up, the same alignment we saw over here when we went to the alignment Y1 and so forth. We're going to see these in much detail later on. So what's going to happen now? Well, the particle is going to move in all sorts of directions as it has been, but at the same time, after each evaluation frame, it's going to turn itself so that it orients the z-axis towards the direction it's traveling. So let's rewind and press play and watch that now. Now it's an airplane. So we turned our particle from a spaceship into an airplane. And I can go here and make this much bigger so we can see the particle traveling in space. And if you want your particles to have orientation, because if you have a sphere or an object that has symmetry, then you don't need to do that. But if you do want your particle to orient itself in the direction of travel, you need to add a look modifier. Excellent. So let me just remove these over here and rewind, and you can see our particle just moving in a straight line. In the same vein, we can tell the particle to do certain things. For example, to turn in a certain direction. And this will turn the way it's moving in that certain direction. So let's try this. What I'm going to do is use a condition, as I did previously, and I'm going to make it a child of the group, and I'm going to tell this when the age is 30 frames and larger, greater than or equals 30 frames, I want the turn to occur, and I want it to turn right. Now, this is not going to work exactly as you expected, and I'm going to explain why. So let me frame my scene nicely here. Press play, and you'll see that it turns in that direction just once, and it doesn't face forwards. So if I tell it to turn again on the x-axis, it won't do that because it's already moving in the x-axis. So what I need to do is not only turn it, but make it look in that direction. So the z-axis turns in this direction. So let's make it look in that direction. Put it after the turn, and let's see what happens now. That's it. Now it's facing in that direction. Fantastic. What if I want my particle now to do this at a regular interval? Well, instead of a condition, and although the condition has a little secret that's hidden under the input math, you can use formulas here to do all sorts of mathematical operations on the properties, but we're not going to get into that yet. We are going to use a time condition. And this time condition deals with time. And I'm going to say, let's pulse, because you can check the scene time. You can pulse this, and you can say, I want to start at frame 30 with a duration of 1 frame and a gap of 30 frames. So every 30 frames, it's going to pulse once, and every time it pulses, it tells anything underneath the condition to do it, right? So it's going to wait for 30 seconds from the beginning of the animation, and then for 1 frame, it's going to say, do it. And what we're going to do is whatever we put underneath it. So let's turn and look. So let's get rid of this condition, and let's see what it's going to do. It's going to turn, and oh, it's not turning. Why isn't it turning? Well, what's happening here is that the turn, it's telling it to turn towards the x of the global coordinates. And this particle is already moving in the x of the global. So we need to tell it to turn in the x relative to its alignment, so this direction. And these are the little details you will get used to slowly. So let's set this to alignment, and now let's see what's going to happen. It's going to wait for 30 seconds, turn, and turn, and turn, and turn, and turn, and so forth. So we need to keep these things in mind, because when it comes to orientations, we not only have local orientation, we have global orientation, we have orientation as compared to its traveling direction, and so forth. And with that, you have a basic understanding of the orientation modifiers, and we are going to introduce all the parameters of all these modifiers in later videos.